OCB. In triangle OCB. Here find sin alpha. Here find sin alpha. Here triangle OCB. Angle is alpha. Opposite to alpha is OC. OC by opposite to 90. That is OB. Okay. OC is nothing but length of the distance between OC, that is P by OB. Now this can be written as OB is equal to P by sin alpha. P by sin alpha. Okay.
Sir, once say how OCB triangle is formed.
Tell me.
OCB triangle you said, no, sir.
OCB. OC is the normal. Normal is nothing but perpendicular.
Yes, sir.
Okay.
Yes, sir.
Angle at O is 90. Here given angle AOC is equal to alpha. The remaining angle is 90 minus alpha.
Okay, sir.
Angle is alpha. Now consider the right angle triangle OCB. From this triangle find the length of OB. Okay. Now we know that intercept form. In this triangle, x-intercept is OA, y-intercept is OB. The equation of a line in intercept form. That is x by x-intercept. X-intercept from the diagram, x-intercept is OA. From the diagram, x-intercept is OA. Okay. Plus y by y-intercept is OB is equal to 1. Okay. X by also OA value is P by cos alpha. P by cos alpha plus y by the value of OB P by sin alpha is equal to 1. Okay. Here cos alpha taken into numerator, x cos alpha by P plus y sin alpha by P is equal to 1. Now multiply with P on both sides. Here P get cancel. X cos alpha plus y sin alpha 1 into P. This is the normal form of a straight line. Is it clear? Once
Yes,
again,
sir.
required the normal form of a straight line, that is this one, which is at a distance from O to C, that is given P, which makes an angle alpha with the positive direction of x-axis. Okay, here OCA form a right angle triangle. Angle at C is 90. Given angle at O is alpha, remaining angle 90 minus alpha. From this triangle, first of all, find the length of OA by using cos alpha. Similarly, OCB is also right angle triangle. Angle at O is 90. Given angle AOC is alpha, the remaining angle is 90 minus alpha. The angle at C is 90. Sum of the angles in a right angle triangle, the sum of the angles in a triangle is 180. So that's why angle at B is alpha. From this triangle OCB triangle, find the sin alpha. From this equation, OB is equal to P by sin alpha. OA is the length of the x-intercept. OB is the length of the y-intercept. We know that the intercept form is x by a plus y by b is equal to 1. After simplification, we got the equation x cos alpha plus y sin alpha is equal to p, which is called normal form of a straight line. Here, alpha satisfies 0 less than alpha less than 360 degrees. P is the distance from origin to the line. P is nothing but the distance from origin to the line. P is distance means it is always positive. P always positive. Alpha lies between 0 less than or equal to alpha less than 360. Okay. This is about normal form of a straight line. Okay. Here two cases are there. Case 1. Case 1. Here alpha is 0 less than or equal to alpha less than 360. Here first case theta is equal to 90 degrees or 270 degrees. Cos 90. The value of cos 90.
0.
Cos 90. 0. The value of cos 270. 0. Okay. So the equation becomes to y sin alpha is equal to p. Y is equal to p by sin alpha. Sin alpha always lies between -1 to 1. So that's why this one is constant. This can be taken as k. So which is of the form y is equal to k. Y is equal to k is nothing but the line parallel to x-axis. The line parallel to x-axis. Once again, we proved x cos alpha plus y sin alpha is equal to p. That is the normal form. Alpha value lies between alpha satisfies the 0 less than or equal to alpha less than 360. The first case is theta is equal to 90 degrees or 270. If theta is equal to 90, cos 90 value is 0. If theta is equal to 270, cos 270 is also 0. So the equation becomes to y sin alpha is equal to p. Y is equal to p by sin alpha. Okay. Sin alpha is always constant value. P constant, sin alpha also constant. This can be taken as k, which is of the form y is equal to k. So any equation y is equal to k, the line parallel to x-axis. The line parallel to x-axis. This is the first case. Is it clear?
Yes, sir.
Second case. Case 2. Case 2. Theta is equal to 0 or 180 degrees. Theta is equal to 0 or 180 degrees. Now substitute these values in this equation, normal form. If alpha is equal to 0,
Process.
sin 0. If alpha is equal to 180, sin alpha is also 0. So the equation becomes to x cos alpha plus x cos alpha is equal to p. X cos alpha is equal to p. Okay. This can be written as x is equal to p by cos alpha. Cos alpha is always constant. P is constant. So it can be total value constant that can be taken as k. So which is of the form x is equal to k. So the line parallel to y axis. Is it clear?
Yes, sir.
Sir,
Tell me.
sir, in that first case, sir, equal to 90 degree or 270 degree. Sir, if we take alpha as 90, no, sir, sin 90 will be 1 only, no, sir. We can even write as y is equal to p, no, sir.
Y is equal to p.
What
If sin theta is equal to 270 minus p.
Yes, sir.
So
So why do we have to write that?
Total value constant.
Okay, sir. So, sir, we can even write that like plus or minus p, no, sir.
Plus or minus k, plus or minus p. So either plus p or minus p, that is constant. That can be taken as k.
Okay, sir. Understood.
Is it clear?
Yes.
Okay. These are two cases for normal form. Okay. Next one. Now convert the general equation into normal form. Now transform general equation into normal form. General equation converted into normal form. We know that the general equation of a straight line is ax plus by
I
plus
plus
c
C is equal to 0.
0. Here two cases are there. C greater than 0, C less than 0. Because the normal form is x cos alpha plus y sin alpha is equal to P. In RHS value, P always positive. Okay. So, if C greater than 0, ax plus by plus c is equal to minus c. C positive, here minus, plus into minus, minus. So, that's why RHS, both sides multiply with minus. In normal form, RHS is always positive. If the case 1, C greater than 0, the equation converted into ax plus by is equal to minus c. C value positive is minus. Positive into negative, negative value. But in RHS always positive. That's why multiply with minus on both sides. That implies minus ax minus by is equal to c. C positive, so that's why this value positive. Okay. Now divide on both sides. Minus a by root a square plus b square on both sides. C by root of a square plus b square. Here a minus a by root of a square plus b square is cos alpha. Y into minus b by this one is sin alpha. Y sin alpha is equal to p. Where cos alpha is equal to minus a by root a square plus b square. Sin alpha is equal to minus b by root of a square plus b square. P is equal to C. C positive, always positive. That's why taken modulus of C by root of a square plus b square. Why divide with root of a square plus b square? First of all, prove that one. See the proof of the normal form once. Here, consider the line equation is ax plus by plus c is equal to 0. Here, consider the equation ax plus by plus c is equal to 0. This can be converted into intercept form. So ax plus by plus c is equal minus c is equal to minus c. Divide with minus c. Ax by minus c plus by minus c is equal to 1. Now x by minus c by a plus y by minus c by b is equal to 1. Okay. So here x-intercept is, so this point a. X-intercept is minus c by a. Here y coordinate is 0. Y-intercept is minus c by b. Here the point taken as b. In y-axis x coordinate is 0. Y-intercept is minus c by b. Okay. Here normal means perpendicular. This one is alpha. Okay. O A C. From this triangle cos alpha is equal to opposite to alpha is AC. opposite to hypotenuse OA is the hypotenuse, OC is the normal, that is T. The OC is the adjacent side and T by OA, PA by P by OA. P by the value of OA is minus C by A. Minus C by A. And then so that's why minus AP by C. Okay, this is cos alpha. Similarly, you can find sin alpha is equal to minus BC by P. Minus BP by C. We know that the identity sin square alpha plus cos square alpha is equal to 1. So, pairing on both sides and they add. So sin square alpha, that is B square P square by C square plus cos square alpha, A square P square by C square is equal to 1. LCM is C square. So B square, in the both terms P square is the common. So A square plus B square is equal to C square. P square is equal to C square by A square plus B square. P is equal to C by root of A square plus B square, plus or minus. So here required cos alpha. Cos alpha means minus AP by C. Okay. Substitute the value of P in cos alpha. Cos alpha is equal to minus A P value. P value C by root of A square plus B square by C. C get cancelled. So cos alpha is equal to minus A by root of A square plus B square. So that's why both sides divided with the root of A square plus B square. That is the reason. Is it clear? Why
So
we take
explain.
this one is sin alpha? The reason is this one. Once again,
Yes, sir.
here we convert the general equation into normal form. First of all, take the constant into right side. The normal form is x cos alpha plus y sin alpha is equal to P. P is always positive. Here first case is C. C greater than 0. Here C taken into right side, that is minus C. C here C positive. Positive into negative, negative value. So that's why first of all multiply with minus on both sides. The equation becomes to minus AX minus BY is equal to C. After that, divide with root of A square plus B square on both sides. The reason is this one. Once again, here this one is the general form AX plus BY plus C is equal to 0. This can be converted into intercept form. So x intercept is minus C by A, y intercept is minus D by B. In triangle AOC, first of all, cos alpha, find cos alpha. Cos alpha means OC by OA. OC is nothing distance between distance from origin to the line, that is P. Okay. X intercept is minus C by A. So cos alpha is equal to minus AP by C. Similarly, we can use OCB triangle from the triangle sin alpha, that is minus B P by C. Here cos alpha and sin alpha is there. We know that sin square alpha plus cos square alpha is equal to 1. So sin square alpha B square P square by C square plus A square P square by C square is equal to 1. After simplification, the value of P is C by root of A square plus B square. After that, substitute the value in cos alpha. The value of cos alpha is equal to minus AP by C minus A. P value is C by root of A square plus B square. Also, in denominator C is there. These two are cancelled. So cos alpha is equal to minus A by root of A square plus B square. So this can be converted into normal form. That's why divide with root of A square plus B square on both sides. So here cos alpha is minus a by root of plus b square. Sin alpha is minus b square. Next p is the distance from origin to the line. Okay. This is about normal form. When c greater than 0. Now discuss about the second case. If c less than 0, second case. First of all, the constant taken into right side, ax plus by is equal to c less than 0. Ax plus by is equal to minus c. C value negative value, here also negative value. So minus of minus plus. So that's why there is no change here. RHS is positive, that's why now divide with root of a square plus b square into x plus b by root of a square plus b square into y minus c by root of a square plus b square. Here x a by root of a square, which is of the form x cos alpha plus y sin alpha is equal to p. Cos alpha is equal to
A plus by equal to C, no, sir?
tell me.
Here ax plus by equal to C, no?
No, here the case is c less than 0.
Yes, sir. This is in the previous case, sir.
In previous case plus c.
Yes, sir.
In this case minus c. Depends upon constant.
Yes, sir.
Okay. Here c less than 0, that's why in RHS minus c. But the total value positive. C value negative of negative, positive.
Okay, sir.
Because always right side of the curve is positive. Okay. So now comparing the equation with normal form x cos alpha plus y sin alpha is equal to p. Cos alpha is equal to a by root of a square plus b square. Sin alpha is equal to b by root of a square plus b square. P is equal to minus c by root of a square plus b square. Here minus c, but total value positive. Okay. Here P is, from this we note that we conclude that P is equal to, the formula is the perpendicular distance, the perpendicular distance from the given data origin, from the origin to the line. Here the line equation is general form. Origin to the line, ax plus by plus c is equal to 0 is, formula is modulus of c by root of a square plus b square. P is perpendicular distance from origin to the line ax plus by plus c is equal to 0. Formula is this one. Other than origin, we prove later. From the origin to the line, the distance is, formula is this one. Modulus of c by root of a square plus b square. Other than 0, we prove later. Okay. This is about normal form. Okay. Now prove the perpendicular distance from px1 comma y1 to the line ax plus by plus c is equal to 0 is modulus of ax1 plus by1 plus c by root of a square plus b square. From the normal form, we proved P is the perpendicular distance from origin to the line. If given other than origin, the formula this one. Origin to the line, the distance between origin to the line, modulus of C by root of A square plus B square. Other than origin, the formula is modulus of AX1 plus BY1 plus C by root of A square plus B square. Now prove this one. In first class, we discussed about translation of axis. Translation of axis means this is the coordinate system. This one is x-axis, y-axis, origin. In this system, P taken as small x comma y. Here apply the translation of axis. Translation of axis. Translation of axis is nothing but the direction of x-axis and y-axis does not change, but origin shifted to other point. Here origin shifted to new point O dash. That can be taken as x1 comma y1. Here direction of x-axis and y-axis does not change the direction of coordinate axis. This is the new axis x dash. This is new axis y dash. We change origin 0 to 0 comma 0 to 2 x1 comma y1. P also changes to new coordinate capital X comma y. So the relation between these three is small x is equal to capital X plus x1 and small y is equal to capital Y plus y1. In this theorem, we prove this one. In this theorem, we use these formulas proving the distance from other than origin to straight line. These are all here apply the translation of axis. Once again, here x-axis and y-axis are old system. Origin shifted to O dash, and there is no change in the direction of x-axis and y-axis. Here x dash y dash is the new system. In the old system, the coordinates of P is small x comma y. We change origin shifted to O dash, that can be changes to P capital X comma y. The relation between these 3 points is small x is equal to capital X plus x1, y is equal to y plus y1. Here we use these formulas. X is equal to capital X plus x1 and y is equal to capital Y plus y1. Okay? This is the translation of axis. Now prove this one. Take the coordinate system. This is the old system O00. The line equation is given general form. This is ax plus by plus c is equal to 0. Okay. Already we proved distance from origin to the line, that is modulus of c by root of a square plus b square. Now origin shifted to O dash. That is the point is px1. This one is p. Origin shifted to p. P is given x1 comma y1. By translation of axis, we cannot change the directions of x-axis and y-axis. This is the new system. This is x dash, y dash. Okay. Now find the distance from P to this line. For new system, P is the origin. For the new system, P is the origin. Okay. So that's why now, first of all, apply the translation of axis. After that, convert the normal form, we find the formula. Okay. Given equation is ax plus by plus c is equal to 0. Okay. By translation of x, the formulas are x is equal to capital X plus x1, y is equal to y1. By translation of axis, small x is equal to capital X plus x1, small y is equal to capital Y plus y1. Why? Because origin shifted to px1 comma y1, so that's why the equation changes to change the equation. So the transformed equation is in place of x we can write x plus x1, in place of y plus y1. A of x plus x1, b of y plus y1 plus c is equal to 0. Now simplify this one. A into capital X, b into capital Y plus the remaining value ax1 plus by1 plus c is equal to 0. Which is of the form ax plus by plus c is equal to 0. Because a constant, x1 constant. So product ax1 is constant. B constant, y1 constant, by1 constant, c constant. So totally these three terms are constant. So that's why this is of the form ax plus by plus c is equal to 0. Now convert it into normal form. Okay. Now convert it into normal form. For converted into normal form, first taken into constant right side. So that's why ax plus by is equal to minus of ax1 plus by1 plus c. Okay. After that, divide with root of a square plus b square. A by root of a square plus b square into x plus b by root of a square plus b square into y is equal to minus of ax1 plus by1 plus c by root of a square plus b square. Here multiply with minus, here minus, here plus. Which is of the form x cos alpha plus y sin alpha is equal to p. Now comparing RHS. P is nothing but origin to the line. Here new origin is p x1 comma y1. So p is equal to modulus of right side value always positive. That's why modulus of ax1 plus by1 plus c by root of a square plus b square. P is nothing but origin to the straight line. The distance from origin to the straight line. Here p x1 comma y1 is the new origin. So this is the formula for the distance from p x1 comma y1 to ax plus by plus c is equal to 0. Is it clear? Once again, by translation of axis, the formulas are small x is equal to capital X plus x1, small y is equal to capital Y plus y1. Here, first of all, consider the coordinate system y x-axis and y-axis. That is the old system. Origin shifted to px1 comma y1. Px1 comma y1 is the new origin. Here x dash and y dash are new coordinate axis. Okay. This is the given line ax plus by plus c is equal to 0. Here required the distance from new origin to the line. Okay. So new origin to the line, that is p. So first of all, the given equation converted into by translation of axis, x is equal to capital X plus x1, y is equal to capital Y plus y1. After substitution, the equation becomes to like this: ax plus by plus ax1 plus by1 plus c is equal to 0. Which is of the form ax plus by plus c is equal to 0. Because ax1 plus by1 plus c is the constant. So that's why which is of the form ax plus by plus c is equal to 0, which is the general equation. Now convert it into normal form. So first of all, take the constant term into right side. Minus of ax1 plus by1 plus c is the right side. In normal form, x cos alpha plus y sin alpha is equal to p. P always positive. That's why multiply with minus on both sides. Minus a by multiply with minus and divide with root of a square plus b square on both sides. Minus a by root of a square plus b square into x minus b by root of a square plus b square into y is equal to ax1 plus by1 plus c by root of a square plus b square, which is the normal form. Yes, finally required p. P is nothing but the distance from new origin to the line ax plus by plus c is equal to 0, which is the required. So, other than origin is given, the perpendicular distance from p x1 comma y1 to ax plus by plus c is equal to 0 is modulus of ax1 plus by1 plus c by root of a square plus b square. Okay, is it clear? Okay, have you any doubt for this today in this section? Have you any doubt?
No, sir.
Tomorrow I will discuss about problems related to normal form and distances. Okay? Take this, sir.
బాలు సార్
Sir.
బాలు సార్ నేను నోగ్రా సార్ని ఫిజిక్స్
Okay.
ఓకే
Okay, sir. Thank you.
ఓకే
సార్
Okay.
నోకరాజు గారు
సార్ గుడ్ ఈవినింగ్
గుడ్ ఈవినింగ్
యా ఓకే
Ranga, sir. Good evening, sir.
థ్యాంక్ యూ బాలు గారు.
Okay, very good evening to all. So today I want to just start methods to locate center of mass. This is very important topic in center of mass. Methods to locate center of mass. Methods to locate center of mass. So 3 methods are there. Actually 4 methods are there, but fourth method just I won't just touch that one actually. And just want to stress these 3 methods. First one is the method of symmetry. Method of symmetry. And second method is method of decomposition. Method of decomposition. And third method is method of integration. Method of integration. So among these 3, which is very important means this is the ultimate method to locate the center of mass in different bodies. So one by one, just I want to discuss method of symmetry. Method of symmetry. So I want to give the just few examples related to method of symmetry. For example, We know that just a symmetry concept, line of symmetry. In mathematics also, we have learned the method of symmetry to develop the graphical representation. Graphical representation. For example, x minus a equal to 0. X minus a equal to 0. What is the line of symmetry for this equation? X is equals to a. X is equals to a. Now here, this is the line of symmetry. Line of symmetry. So we know just very well about the line of symmetry in mathematics. So the same concept just we can apply in physics in center of mass concept. So what is method of symmetry here? For example, if you consider the disk, this is a disk. This is a disk. So I said already in the previous classes, two important points. For uniformly distributed massive bodies, the center of mass exactly located at the geometric center of the given body. That is the first point. If it is non-uniformly massive bodies, the center of mass does not exactly locate at the center of exactly center of the given bodies. Center of the given bodies. These are very, very important points. Now here coming to the point now, this is disk. So this is a regular body. This is a regular body, and one more point, this is uniform disk, considered a uniform disk. Uniform disk. What is uniform? What is uniform? So here just I want to stress 2 points. Number one is uniform is nothing but the material is the throughout the material the composition is same. That means same composition. Same composition. Throughout the material consists of same composition. Otherwise, just we can discuss about same density also. Same density. In some body, just we are discussing about volume with respect to density. Volume with respect to density. Same density. Same density. So, why it is called uniform? This means so it is a combination of same composition and also same density. That's why this is called uniform disk. For the case of uniform disk, this is center of mass. This is center of mass. The center of mass located exactly at the center of the given body. Center of the given body. If you draw the lines for this body, where the all lines intersect one point, that point indicates center of mass of the given body. Center of mass of the given body. So this is the one of the example. And one more example. One more example. Triangular plate or triangle. Triangle. So where is the center of mass of this body? Exactly center of the given body, like this one actually. To draw the just line of symmetry for this body, where these all lines just meet at a single point, that point indicates center. So the center indicates center of mass. Center indicates center of mass. Now, this is called geometric center. This is called geometric center. And coming to the next one, for better understanding, just I want to give one more example. This second example and third example. Uniform rod. Uniform rod. Uniform rod. So, for example, this is a uniform rod. This is uniform rod of length some L. Of length some L. Where is the center of this body? Actually, this is the center of this body. So, where is the center of mass? Exactly this point. Center of mass located at this point. Actually, this is C. Because of this is the half of the just length of the body. L by 2. This is also L by 2. So, where is the center of the body given? Actually, here, according to the information, center of mass exactly located at this point. Because this is a geometric point. Geometric center also. Geometric center also. These are the few examples of Method of symmetry. So based on the method of symmetry, just I want to just give one more example. So next. For example, if you consider this is a small disk, this is a large disk. Just assume this is a small disk, this is a large disk. So this is the center of the disk. Let it become C. This is the radius of the disk R1. So this is the center of the disk, like C. This is the radius. This is the radius. Now here, this is a disks of same density. So what are the characteristics here? These two disks are the same material, and coming to the next one, same densities also, and same thickness. So here, same density, same thickness. These are the properties of the given disk. Same thickness, same thickness. Now here, how to calculate the center of mass of this system? Center of mass of this system. So here, just two different bodies are there actually. One is a small disk, and another one in the another one is a large disk. Now this is the R1, this is R2. How to calculate the center of mass of the system? How to calculate the center of mass of the system? Just I want to indicate like this. Let us consider this point named as C1 and C2. Like C1 and C2. So what is the total distance? R1 plus R2. From this point to this center to this center. Like C1 to C2. Right? I said one point. If you want to calculate the center of mass of the different bodies or system of the bodies, one should be constant or fixed. One should be constant or fixed. So automatically we can just find out the center of mass with respect to second condition, second body. Now here also just I want to fix this point. I want to fix this point. Now here, if you are considered just this point is fixed, what happens? Let it be considered this is the x1 equal to 0. x1 equal to 0. What about x2 value? What about x2 value? x2 equal to r1 plus r2.
R2.
Yeah. So here x1 equal to 0 because of this is a fixed point. I consider it as a fixed point. So this is x1 equal to 0, automatically x2 equal to r1 plus r2. So we know that just xcm equal to like m1 x1 plus m2
X2
by m1 plus m2. M1 plus M2, right? These are the disks. So we know the just volume and also density. Now how can we capture this is mass, this is displacement, or just a position vector. So how can we capture just this total value? Now here density equal to mass by volume. Okay, mass is equals to density into volume. Now we can simply write density equal to mass by volume. So therefore, mass is equals to density into volume.
Density is
Density into volume. Now here we can write density. I consider as rho. Volume is nothing but area into some thickness, because of I given just one condition. So these two bodies have same thickness. So that's why just I want to consider area of this one pi r square into thickness. Pi r square into thickness. This is very important. So substitute the value instead of m. So now here m means rho into pi into R1 square T. Okay. R1 square T. What about this one actually? This is 0. This is 0. So what about this value? Remaining value. Can I write? M1. What is M1 value? What is M1 value? M1 into what about X1 value? 0. The total terms become 0. The total terms become 0. Directly just I want to write this remaining part. So simply we can write M2 into remaining part. So here it means rho into pi into what about the second one? R2 square pi R square. R2 square into thickness into total mass, total distance. R1 plus R2. Is it okay? By what about remaining? So remaining also we can write remaining rho into pi into R1 square P plus rho into pi into R2 square into T. Right? So what is the final answer? So here rho into pi into R2 square, okay, T into R1 plus R2. So here just take common rho into pi into into T also constant. So remaining terms R1 square plus R2 square. So here rho get cancel, pi cancel, T cancel. What is the final answer? R2 square into R1 plus R2 by R1 square plus R2 square. This is the answer for this. This is the axiom. This is the axiom. Please write up. So here these two are small and large discs of same density and same thickness. This is the condition, primary condition to establish the center of mass of the system. So what is the meaning of this last formula? What is the meaning? Just what is the conclusion from this mathematical approach? Are you getting this point?
Yes, sir. Yes,
Okay.
sir.
What is the meaning of this final formula?
Center of mass of two circular discs.
So two circular. Where from it is actually the distance of center of mass from center of small. That is the final conclusion. Please write on that point. Please add that point. Distance of after this one. Please write down. Distance of center of mass. Distance of center of mass. Distance of center of mass from center of mass from center of small disk. Center of small disk. Same manner, just I want to consider the spheres. Small sphere and also large sphere. So what is the center of mass? I want to consider. This is a sphere. This is a large sphere. So in a sphere, we did not just discuss about thickness. Only we are talking about the only density. What is the primary condition here? Same density of these two. Same density.
Same thing.
This is a center. This is also center. Radius R1. This is the radius R2. So can you find out? Same manner like discs concept. So here also same. This is C1, this is C2, like C1, like C2. The distance between these 2 points R1 plus R2. Here also like x1 equal to 0, x2 also equals to R1 plus R2, like before for problem. Now here xcm equal to m1 x1 plus m2 x2 by m1 plus m2. Now here what is m1? Here we can write just density equal to mass by volume. Density equal to mass by volume. What about mass value? Mass is equals to density into volume. Density means rho, volume means sphere volume, 4/3 pi r cube. Volume of the sphere equal to 4/3 pi r cube into rho. This is the value for just m. So directly just I can substitute here. This value becomes 0. Directly I am writing just 4/3 pi r cube into rho, pi r cube into rho. Okay. But here pi r2 cube into rho into r1 plus r2. By whole divided by remaining terms. Please be ready. 4/3 pi r cube pi r1 cube into rho plus 4/3 4/3 pi r2 cube into rho. So now here in this terms take separate 4/3 and pi into rho. Now here 4/3 pi into rho r2 cube into r1 plus r2 whole divided by 4/3 pi into rho is separate remaining terms r1 cube plus r2 cube. Now here 4/3 pi rho get cancelled. Finally, what the answer? xcm equal to r2 cube into r1 plus r2 whole divided by r1 cube plus r2. This is the answer. Please read. So similarly here also the distance of center of mass from center of small sphere. Please add that point also finally. Center of sphere. Students, are you writing?
Yes.
Yeah.
Yes, sir.
So got the idea about this one?
Yes, sir.
Okay, please write up. So how can you calculate the center of mass of different combination of bodies? Different combination of bodies like same category of just materials, but sizes are different. Sizes are different. So this is the approach to calculate that one. Next, one more example. I consider thin uniform rods. Thin uniform rods. I would like to arrange just a shape like as this is a uniform rod. This is a uniform rod of length L. Length of this uniform rod equal to L. Okay. So this is one more just uniform rod. This is like a T shape, like T shape. Same material, T shape. So what is the center of this uniform rod? Exactly at the midpoint of this uniform rod, right? This is the center of mass of the given body. Like I consider it as C1. C1. What about this one? This one also, the length of this rod equal to like L. Like L. So this can be considered as C2. This is center of the given rod. So for this rod, this is C1. For this rod, this is C2. So how to calculate the center of mass of this system? Now this is just if you are going to extend this one, going to extend like this for comfortability. I said one point. First you have to pick the one point. So this is a fixed point. I want to fix this point. So now here, this is C1, this is C2, this is it. I consider this is the origin. This is the origin. This is origin. Right? So the length of this one. What about length of this one actually? What about the length of this one? L. What about length this one? L by 2.
L
This
by
one
2.
L by 2. Okay. L by 2 and L by 2. So just assume where is the center of mass of the system? Maybe lies in the just boundaries of given area. Like just the midpoint of just C1 and C2. Like here. Maybe. So we are going to calculate the center of mass of the system. Center of mass of the system. Now just I would like to consider this is like just y-axis. That's why I consider as y1. If you want to just consider the x, no problem. Y1 equals to some L length. And what about this one? This is y2. You have to consider it. Y2 equals to, I consider as y2. Y2 equal how much it is? L by 2.
2.
Equal to L by 2. Right? Just I consider these all points to find out the center of mass. I consider just this is the vertical, that's why YCM. I want to calculate the YCM value. So therefore YCM equal to YC M1 Y1 plus M1 Y1 plus M2 Y2 divided by M1 plus M2. So here Y1 equal to how much it is? What about Y1? Y1 equal to L.
L.
Okay. Y1 equal to L. Just you have to leave the M values because of in the numerator and also denominator both will cancel. No need to just change it. Okay. So now M into Y1 equal to L plus M to M. Y2 equals to L by 2.
By 2.
Whole divided by M1. Just M plus M. M plus
Sir,
M. Yes.
how Y1 is equal to L, sir?
Y1 equal to
L, how, sir? The L is the length of second rod, right, sir?
this one actually. This is actually how much it is actually
L, sir.
L. So this is equal to L. But this is very small width actually.
Yes,
So
sir.
that is negligible.
Okay, sir.
Okay.
Yes, sir.
If you are just to consider that point also, we are going to utilize just an integration part. No need to just use the calculus method to develop the just HCM or YCM. Okay,
Okay,
that is
sir.
very visible. That's why I consider just to this can be
L.
L. Okay. Now here M is common, so L plus L by 2 by this is 2M like 2. So 2L 3L by 2 by 2. Finally, what is the answer? 3L by 4. 3L by 4 is the YCM. This is the answer. 3L by 4 is the YCM. Any doubt in this?
No, sir.
Actually, just this part, just connecting to this part actually. Up to here.
Okay,
Okay?
sir.
So
Yes,
that's
sir.
why we cancelled as just L, no problem.
Okay, sir.
Next, coming to the next problem. Next, shifting center of mass. If a rod is bent at its middle or center, middle means midpoint, middle or midpoint. Like, so now here this is also rod. This is rod. So length of this rod equal to similarly like L. This is L. So actually this is the center of the given rod. Center of the given rod. This is C. This is the center. This is C. So according to given shifting center of mass, if a rod is bent at its midpoint. So if you are considering just a midpoint, so this one just bent into the form of just some different shape like this. Now here, this is the one of the shape actually. Like this, is bent like this. Okay, draw the diagram. Actually, this is a uniform rod of length L. Automatically, this one equals to L by 2, this one equals to L by 2. L by 2 and L by 2. Right? Now here, if you consider this should be L by 2. Where the center of mass of this one? Where the center of mass of this one actually? Here L by 4 and L by 4. This is center of mass. About this one, L by 4, L by 4. This is the center of mass of this rod. So where is the just center of mass of these two bodies? Like exactly midpoint of the given body. Midpoint of the given body, like this one. This is C1. I consider this is C1. This is C2. This is C1. This is C2. And what about just center like C? This is the midpoint of the just given shape of the body. Given shape of the body. Like C dash. You have to consider C dash. For better understanding, just I want to give you just this diagram. You can understand very easily. Now this is theta. This is theta. Where is the center of mass actually? This is the center of mass. Like C1, C1. This is like C2. Where is the center of mass of these two rods? Exactly this point. This is the center of mass of this, like C dash, whatever maybe, no problem. C dash. So this is the center of mass. Now I said already, this is L by 4. Automatically this one also equals to L by 4. Because of this is L by 2, this is L by 2. So this is L by 2 overall. L by 2 divided into two parts like L by 4, L by 4. Right? Now here, where is the center of mass? This is the center of mass actually. This is the center of mass point. So here you have to divide it into just the center of mass point. Now let it because this is the x. This is the x. Angle divided into two parts. This is x. Like theta by 2. Like theta by 2. This is theta by 2. So you have to calculate any value. Like cos or cos theta, you want to calculate cos theta. Cos theta equal to whatever cos theta value adds by hypotenuse. Here adds is nothing but adds are equal to x by whatever hypotenuse. Hypotenuse equals to L by 4. L by 4. Therefore, x is equals to, simply we can write the L by 4 cos theta by 2. L by 4 cos theta by 2. So this is the x value. What about x value? The distance from center of mass to origin. Origin. That is the x value. This is also very, very important point. Please write down. Again, I want to explain. Add any doubt. So here, what is x value? The distance from origin to center of mass. That is x. So we are going to calculate the x value. That should be center of mass value from the origin. So finally x equal to L by 4 cos theta by 2. Students, any doubt?
No, sir.
Okay.
No, sir.
Are you getting?
Yes. Yes, sir.
Okay. So this is about line of method of symmetry. So in these all problems, just we considered only symmetry concept. So like this is L by 2, L by 2. The concept of symmetry. These all problems just solved by the method of symmetry concept. Next one is a method of decomposition. Method of decomposition. Can I have this? Next method of decomposition. Method of decomposition is nothing but divided into parts. Divided into parts. Like just for better understand, just I want to consider one example. Best example from the nature, elephant. When we observe the mass of the elephant, that is very, very huge value. Like elephant, like blue whale. So these all are just consist more massive bodies. More massive bodies. How can we calculate the center of mass of that elephant or a blue whale? First, we are going to divide it into parts. Divide it into parts. So individual part, just center of mass. First, you have to calculate. Then have to just find out the total mass to center of mass. That is the best example of decomposition method. Just I want to give just one example. Now, this is the elephant. Just how to understand. Now, this is the trunk of the just elephant. Now, this is a tail. Just now here, these are the just legs of the elephant. Right, okay. Now here, try to understand this diagram. Now this is a trunk actually. This is a trunk. This is a trunk. So here, just I want to divide it into different parts. Like this is a trunk. This is body. It's totally body. This is like tail. These are the legs. These are the legs. Now just I want to consider the different center of masses of different bodies. Okay, of different masses, of different masses. First, I want to consider the center of mass like C1. Center of mass of this part like C2. Center of mass of this body like C3. Center of mass of this leg like C4. Center of mass of this leg like C5. Center of mass of this leg like C6, like C7, like C8, like C8. These are the possibilities. Now here, if you want to consider the just masses also, like if you consider the just mass, like M1, C1, M1, C1, like M2, this is M1, M2, C2, M3, C3, M4, C4, M5, C5, M6, like C6, M7, like C7, like M8, C8. So we know the formula. What is the formula? For discrete particle center of mass formula. Like M1x1 plus, M2x2 plus, M3x3 plus, and so on. Mn xn formula we had. So we are going to just utilize that formula. We can calculate the center of mass of the total body, the total system. So this is the approach to calculate the center of mass of any just body by using decomposition method. Just this is the example to understand the method of decomposition. Understand the method of decomposition. Just I want to give one example. This is the best example to understand the method of decomposition. Please write down everything. This is the just initially just how to understand the decomposition method. Simply remember, decomposition method is nothing but divided into parts. Then after just to find out the center of mass of the any body. Center of mass of the any body. Whatever it may be, uniform or non-uniform. Right? Next. Next, I want to give one example based on the decomposition method. So this is very, very important problem. Yes, this is the given just system. Now just I want to consider the values. This is origin. This is like 10. This is like 10. Exactly this point like 10. This is 20. This is 20. And this is 30. This is 30. This is 10. This is 20. Similarly, this is 30. How to find out the coordinates or center of mass of the system? Center of mass of the system. So this problem solved by just decomposition method. We can solve in different approaches, but which is the easiest way? I want to discuss that point. Now here, how can you just divide it into components or parts? So what are the possibilities? If you are just divided like this, divided like this. So this is one part, this is one more part, this is one more part, one more part. You have to just consider this is one more part. 1, 2, 3, 4, 5, 6. If you want to just divide it into like 6 parts, then you can calculate just to center of mass. This is one approach. And coming to the next one, another approach is I want to just consider only 3 parts. 3 parts only. Now here just I consider this part. 1, 2, 3. I consider 3 parts. So basically, remember here one point, mass is directly proportional to area. This is very, very important to develop this problem. When mass increases, automatically area also increases. So we are not just to consider density and thickness and volume, whatever it may be. Simply we can consider area to get the answer. So this is the shortcut method. Now here I want to consider the coordinates of center of mass of the given system. This is uniform metal sheet. Just you have to consider this is uniform metal sheet. Uniform metal sheet. Metal sheet. How can you calculate the uniform metal sheet to center of mass? So coordinates of the uniform metal sheet center of mass. Okay, right? Like HCM. You ask only like HCM and YCM. HCM and YCM. How much it is? I want to calculate. What are the coordinates? First, I want to calculate the coordinates of center of mass. How can you calculate the coordinates of center of mass? So here I considered first how many possibility of center of masses are there in the given metal sheet. I want to consider that point. Now, just I want to consider. Now here, this is the one point actually. 0 to 10. What is the midpoint? This is the midpoint. Assume just this is the midpoint. In along the x-axis, 5. Simply, this is 5. Okay, along the x-axis. Coming to the just y-axis. Coming to the y-axis. So where the y-axis center of mass actually I considered here. From just 10 to 30. 10 to around 0 to 30. 15 exactly. 15. So like 15. This is 15. This is 15. Now this is the first center of mass like C1. First center of mass like C1. Students, are you able to understand?
Yes, sir.
Are you there?
Yes, sir.
Yeah.
Yes, sir.
Concentrate here, okay? Now here, from 0 to 10, what is the center of mass? Actually, center of these two is 5. So from 0 to 30, what is the center of the point? 15. Just let it be considered as C1. This is C1. Coming to the next one. Next one. So what is the coordinates of these two? C1 coordinates like 5 and 15. Got it? And coming to the C2. Next is C2. Now here this is the C2 value. This is C2. Right? Now here, what about just center of mass of the second condition? Second condition. Now here, from 10 to 20. 10 to 20. What is the center of point? 15 up?
Yes, sir.
15. What about this one actually? The center of mass equal to from here 5. This is 5. Am I right? This is 5. And what about this one? What about this one?
15.
15.
15 and 20. Second condition. This is the first part. This is the second part. Tell me now.
Sir, 20.
20?
20, sir.
Yes, exactly. This is the 20 point. Now here this is 20 and this is 5. So for the this is C2. This is C2. C2 equals to 20 comma 5. Right? Go for the C3. Where is C3? This part is C3. This part is C3. Now this part. Now here this is the C3 part. 10, 20. Between this is 15 actually. Like this. Okay, this is C3. What about this one? 30 and 25. Midpoint equal to 25. Like 15, 20, 5. These are the coordinates of or center of masses of different systems actually. This is C2, this is C1 and C3. Now just I want to consider the area of this one. Area of this one. Just I consider as this is A1. A1. What about A1 value? A1 equal to, this is the A1. A1 equal to 10 into this area. Like side into side. 10 into 30. This 10 into 30. Don't confuse the numbers. Okay now. 10 and 30. Total value. 30. 10 into 30. Here the area. And what about this one? Second A2 value. A2 value? A2. 20 into
10.
this is 20. 20 into 10. 20 into 10. This is 20. And what about this one? This value equal to 10. 10 into 20, 200. Coming to the next one. A3. What about A3 value? A3 value. What is the difference? 30 minus 20.
38 and
10 and 10 and what is the remaining part? 10. 10 into 10. Okay, now these are the values of area of the given metal sheet. So then go for the just XCM and YCM. XCM equal to M1 X1 plus M2 X2 plus M3 X3 by M1 plus M2 plus M3. Right? What about M1 value? So remember children, here M1 is nothing but area directly. Area value just I want to consider. Right? What about M1 value? M1 is nothing but this one. 10 into 30, like 300 into what about X1 value? What about X1 value? X1, 5 plus what about M2 value? 20 into 10, 200. 200. What about X2 value? X2
20.
value 20. 20 plus M3 is nothing but 10 into 10, 100. 100 into what about X3 value? Last X3 value?
15.
15. Alright. 15. Total mass. Total mass is 300, 200, 600 totally. Simplify this value. Totally 1500. Finally, what is the answer?
70 by 6.
70 by
6.
okay, 70 by 6. So in this problem, we can substitute density and also just remaining terms also, but no need to just consider those values. In denominator value and numerator value both will cancel finally, so you will get the same answer also. So this is the easy approach to find out the HCM value for the given metal sheet, uniform metal sheet. Go for the YCM. Go for the YCM.
80 by
Calculate
6.
YCM value. Here, don't confuse the just coordinates. That is very important.
80 by 6. 80 by
Coordinates
6.
X and Y values. Now calculate the YCM.
80 by 6.
80 by
6.
6. Okay. Now calculate the YCM also. YCM equal to, okay, M1 Y1 plus M2 Y2 plus M3 Y3 4 divided by M1 plus M2 plus M3 4 divided by, what about M1? Same values, but here Y values are different. So 300 directly into what about Y1? Y1 equal to, I calculate 15 plus M2. M2 was A2. 200 into Y2 value. What about Y2 value? What we consider Y2 value equal to 5. Plus 100 into, what about Y3 value? Y3 value
5.
25. Yes. By 600. So finally what you will get?
80 by 6.
80 by 6. Very good. Okay. 80 by 6. So how to solve this problem? By using method of decomposition. By using method of decomposition. Okay, right? Next one is the method of integration. Next one is
Once
Hello?
please explain again the area, sir.
area, na?
Yes, sir.
Yeah, okay. Now just first identify the coordinates. That is very, very important. Area means this is the one part. Try to understand this one. This is one part. I want to use just color chalk. This is one part. Okay? 0 to 10. 10 into 30. This is the first part. 10 into 30. That is the A1 value. Okay, right? This is the A1 value. Coming to the second part. What is the second part we consider? This is the second part. Right? Second part equal to this one. Now here, what about you know the just coordinates? Second part area. What about second? This is the second part. And this is the third part. This is the third part. Coming to the second part area. Now this is the center of mass of the second part. 20 into 10. Try to understand this point. This is the 20 part. Where the center of mass is located up to there actually. 20, 0 to 20, 20 into 10. This is the second part area. Okay, got it? And the third part, go for the third part. So now here, this is the center of mass actually. Center of mass. Right? This is 10. This is 10. So between these two, what about this part actually? This is 10. And what about this one? Remaining part. What is the difference between these two? 10. 10 into 10, 100. Children got it? Any doubts?
No, sir.
So how can we calculate the area of the rectangle? Just we can follow the same manner. But here, just you should identify the coordinates are very, very important for the different metals. Coordinates, how to just locate the coordinate points. Those are very, very important. If you know the coordinate points, automatically you can calculate the areas of the given body. Areas of the given body. Right? So this is about method of decomposition. Method of decomposition. Any doubt from here? From starting onwards. We have discussed about method of symmetry and method of decomposition. In these two concepts, you have any doubt? Please raise the doubt.
If you have any doubts, please ask.
Sir,
Yeah.
You told it a shift in center of mass if rod is bent its midpoint. No, sir. Once can you repeat it again?
Which one? Which one?
Shift in center of mass when a rod is bent on its midpoint.
Yeah. So in that example, actually this is a uniform rod. Uniform rod of length, how much it is? L. Okay. So what is the center of mass exactly located at the center of the given body, like C. So this is the center of mass of the given body. That means what is the separation point actually? This is L by 2 and also this is L by 2. Is it okay?
Yes, sir.
But this is just bent at its midpoint. So like this is actually bent like this. So like this is a rod, you have to assume. This is a rod bent like this. This is bent like this. Okay?
Okay, sir.
Bent like this with certain angle. Now here, this is a bending condition. Right? This is the one point. This is one more point. Now try to understand. So actually this is L by 2. This is L by 2. Automatically this one also L by 2. So if you are going to calculate this is L by 2. This is L by 2. What is the center of mass of these 2 points? L by 2. If it is L by 2, what is the center of mass of these 2 points? Like L by 4, like L by 4. Am I right?
Yes, sir.
So what is the center of mass means this is L by 4 and also this is L by 4. If you consider that this is C1, if you consider this is C2, where is the center of mass? This is C dash. Okay, now the separation angle equal to theta. Right? Now simply you can understand like this. So this is theta, this is L by 4, like this is C1, C1, like this is C2, where the center. So which angle is sufficient to calculate the x value? Cos angle. Here. This is total angle equal to theta by 2. This is equal to theta by 2. Simply we can calculate cos theta by 2 equal to like x by this is also L by 4. L by 2. So finally x equal to L by 4 cos theta by 2. So is there any doubt here?
No, sir.
Okay. So here you have to identify one important point. So length divided into just like center of mass lengths. So like divided into 2 equal parts. Right? Any doubt?
No, sir.
Today must be for integration formulas. Tomorrow I will start the method of integration.
Thank you very much, sir.
Thank you, sir. Thank you very much. Thank you.
Thank
children.
you, my dear children. So tomorrow we will meet again. Thank you very much.